Hi friends, this is Manjunath from Anvit Tuition. So today we are going to do the continued part of trigonometric identities. That is, so first problem here we are going to do prove that 1 minus sin theta by 1 plus sin theta is equal to sec theta minus tan theta. First we are going to write here, consider LHS 1 minus sin theta by 1 plus sin theta. First we have to do rationalize the denominator to get the RHS. So RF factor of 1 plus sin theta is 1 minus sin theta divided by 1 plus sin theta. We will write as it is. RF factor of denominator 1 plus sin theta is rationalizing factor. RF factor in the sense rationalizing factor, that is 1 minus sin theta divided by 1 minus sin theta. So numerator we will write in the nearby form, 1 minus sin theta by 1 minus sin theta whole divided by, this is in the form of 1 plus sin theta 1 minus sin theta. I will return nearby form. This is of the form, a plus b into a minus b identity. That is, we will write this is in the form of a square minus b square. So denominator I will write in the form of a square minus b square. This is 1 minus sin theta is 2 times 1 minus sin theta. I will write it square. So denominator I will write it this identity, that is 1 minus sin square theta. So 1 minus sin square theta is equal to cos square theta. Here 1 minus sin theta whole square divided by 1 minus sin theta in the sense cos square theta, that is identity once again, that is sin square theta plus cos square theta is equal to 1. Here we need 1 minus sin square theta. 1 minus sin square theta is equal to cos square theta. So both the numerator and denominator are in the square form. I will take numerator and denominator whole square, that is 1 minus sin theta by cos theta whole square. I will do it. So this is equal to, denominator I will split into two form, 1 minus cos theta minus sin theta divided by cos theta whole square. Once again here 1 minus cos theta, reciprocal relation is sec theta. Sin theta by cos theta we will write in the form of tan theta. So this is RHS form, hence proved. Okay, next problem is prove that sec theta into bracket 1 minus sin theta sec theta minus tan theta is equal to 1. Here also we are going to consider first LHS. LHS is equal to sec a into bracket 1 minus sin a into bracket sec a minus tan a. Here reciprocal relation I am going to take. Sec a is written in the form of cos a, and 1 minus sin a I will write it as it is, and sec a I will take a reciprocal of 1 by cos a. Sec a is written in the form of reciprocal 1 by cos a, and tan a is a ratio is sin a by cos a. So these two I will write it as it is, 1 minus sin a by cos a. In the bracket I will take an LCM over here. LCM becomes cos a, LCM becomes cos a, and here numerator becomes cos 1 are 1 minus cos 1 are 1, that is 1 minus sin a. Both numerator and denominator I will write it in nearby form, 1 minus sin a and 1 minus sin a whole divided by this one cos a into cos a, that is we can write it dot only. Okay, now this is 2 times. Actually I will write this one in the form of sin a whole square whole divided by cos square a. It becomes cos a into cos a becomes a cos square a. Here once again I will write this one as it is numerator 1 minus sin a whole square whole divided by cos square a cos square a. So 1 minus sin square a. Okay, so numerator is of the form a plus b into a minus b. Numerator is of the form a plus b into a minus b. We can write this one is a square minus b square. That means 1 minus sin square a by cos square a. 1 minus cos square a, we can write this one as cos square a by cos square a. Cos square get cancelled 1 RHS, hence proved. Here 1 minus sin square a is equal to cos square a identity. Okay, next problem is prove that cot theta minus tan theta is equal to 2 cos square theta minus 1 divided by sin theta into cos theta. Here also we are going to first consider LHS. LHS is equal to cot theta minus tan theta. Cot theta reciprocal, we will write this one is in the form of cos theta by sin theta minus sin theta by cos theta. So here we are going to take an LCM denominator. Denominator LCM becomes sin theta into cos theta. If you first denominator, if you divide the LCM by sin theta, it remains cos theta only over here. And here if you divide cos theta by LCM, so cos theta get cancelled, sin theta it will comes cos theta into cos theta becomes cos square theta minus this one becomes sin square theta. So here what I will do, so here we have to prove 2 cos square theta. What I will do for sin square theta, we know the identity, that is sin square theta plus cos square theta is equal to 1. Here we needed sin square theta, so sin square theta is equal to 1 minus cos square theta. I will substitute this one. So here cos square theta minus into bracket sin I will put this one 1 minus cos square theta. So whole divided by sin theta into cos theta. So here I will multiply this bracket by minus. So cos square theta minus 1 minus into minus plus it becomes cos square theta whole divided by sin theta into cos theta. Here cos theta plus cos theta becomes both are positive. It becomes 2 cos square theta. So here 2 cos square theta minus 1 whole divided by sin theta into cos theta. Hence proved. This is the RHS. Okay, again here also same the earlier problem what we have done. It is tan theta minus cot theta. Here we are going to prove 2 sin square theta minus 1 divided by sin theta into cos theta. Earlier problem here 2 cos square theta we have proved. Here we are going to prove 2 sin square theta minus 1 divided by sin theta cos theta. So here also same the thing. Here first consider LHS tan theta minus cot theta. I will write these two things in the reciprocal form. Sin theta can be written in the form of sin theta by cos theta minus cot theta written cos theta by sin theta. Here I am going to take an LCM cos theta into sin theta. If you divide this LCM by cos theta, here cos theta get cancelled, sin theta will remain here. And here also sin theta, if you divide by LCM, sin theta get cancelled, cos theta comes, sin theta becomes sin square theta minus cos theta becomes cos square theta. Okay, here RHS we are expecting in the form of 2 sin square theta. What I will do for cos square theta identity, I will put as 1 minus sin square theta. Identity is sin square theta plus cos square theta is equal to 1. Here we needed cos square theta. Cos square theta, I will keep it here. I will transfer this one to sin square theta. So by cos square theta, I will put 1 minus sin square theta because we need RHS in the form of 2 sin square theta. So sin square theta minus into bracket other than cos square theta 1 minus sin square theta whole divided by cos theta into sin theta. So next step I am going to multiply with minus 1 here. So this numerator becomes sin square theta minus 1 minus into minus becomes plus sin square theta whole divided by cos theta into sin theta. So sin theta 2 are there, plus in the sense 2 sin square theta 2 sin square theta are there minus 1 divided by cos theta into sin theta, hence proved RHS. Okay, next problem here. Prove that cos square theta by sin theta minus cosec theta plus sin theta is equal to 0. Here also we are going to consider LHS first. LHS is equal to cos square theta by sin theta minus cosec theta plus sin theta. What I will do, cosec theta I will take it as a reciprocal. Cos square theta by sin square theta I will keep it as it is minus cosec theta 1 by sin theta. Cosec theta is 1 by sin theta reciprocal. Sin theta I will keep it as it is. So here if you want to treat this one as 1 is present in denominator, so whole LCM I will take here denominator. The LCM becomes here sin theta. If you divide sin theta, 1 the sin theta, 1 the. So 1 sin theta becomes sin theta. So cos square theta, here sin is minus 1 1 the 1, middle sign is here plus sin theta into sin theta becomes this one becomes sin square theta. So I will these two becomes identities. I will join these two, cos square theta plus sin square theta minus 1 whole divided by sin theta. So cos square theta plus sin square theta becomes 1 because that is the identity. Sin square theta plus cos square theta is equal to 1. This one I will here I will put it as 1. 1 minus 1 whole divided by this one is sin theta. Anything 0 by sin theta it becomes that is equal to 0 RHS. Okay, here next problem is cosec a divided by cosec a minus 1 plus cosec a divided by cosec a plus 1 is equal to, we have to prove 2 sec square a. Okay, so here also we are going to consider LHS is equal to cosec a divided by cosec a minus 1 plus cosec a divided by cosec a plus 1. Here I will take in denominator LCM. Both LCM becomes the same here. That is cosec A minus 1 LCM cosec A plus 1. Denominator ಯಾವ ಇರ್ತವೋ ಅವೇ ಎರಡು LCM ಆಗಿಬಿಡುತ್ತೆ ಇಲ್ಲಿ. So we have to divide cosec A minus 1 by with these LCM. So this get cancel ಆಗುತ್ತೆ. ಇದು ಕ್ಯಾನ್ಸಲ್ ಆದಾಗ ಇಲ್ಲಿ ಏನು ಉಳಿತಿತ್ತು ನಮಗೆ cosec A plus 1 ಉಳಿತಿತ್ತು. Cosec A plus 1. Here if you divide cosec A plus 1 to LCM, plus will get cancelled, cosec A minus will remain here. Cosec A minus 1. We have to multiply this one. That is cosec A into bracket cosec A plus 1 plus into bracket cosec A as it is here. Cosec A into bracket cosec A minus 1. Okay, so what I will do, I will multiply cosec A with this bracket plus and again cosec A with this bracket. We will multiply cosec A becomes cosec square A plus cosec A ones are cosec A. Now again here also cosec A becomes cosec square A plus into minus cosec A. Cosec A into 1 is cosec A all divided by LCM as it is, that is cosec. This is of the form, denominator is of the form A plus B into A minus B. What I will do, this one cosec square A minus 1 I will write. Cosec square A minus 1 I will write this one. So this becomes okay. So this is equal to the here plus 1 minus cosec A get cancelled. Cosec square A 2 are there, that is 2 cosec square 2 cosec square A divided by denominator cosec square A minus 1 square A. So here for denominator we are going to put cosec square minus 1 I will write. This is in the form of 2 cosec square A. This one cosec square minus 1A in the sense cot square A, because we are going to put an identity over here. Cosec square minus 1 is equal to cot square, that is this is equal to cosec square I will write in the form of that is here we will write this one cosec square A minus 1 is equal to cot square A. Okay, so cosec square we will write in the form of sin square A all divided by cot reciprocal is uh, cos square A by sin square A. So this is equal to the 2 by sin square A, it becomes numerator all divided by cos square A by sin square A. So this becomes this is division, actually it becomes reciprocal over here if you take numerator. So sin square A into sin square A by cos square A. So sin square get cancelled. So here it becomes 2 by cos square A. Here our RHS is 2 sec square A. 1 by cos square A we can write in the reciprocal sec square A. So this is equal to RHS, hence proved. Okay, here next problem is sec theta plus tan theta is equal to x. Then sec theta is equal to 1 plus x square 2x we have to prove here. So first before going to solve, consider this given equation, that is sec theta plus tan theta is equal to x. We will take this equation number 1. We know that identity, that is sec square theta minus tan square theta. Sec square theta minus tan square theta is equal to 1, we know. So from this one, this is in the form of we'll consider this identity and we are going to prove the same sec theta is equal to 1 plus by 2x. This is of the form a square minus b square. This one I will write, this one is in the form of a plus b into a minus b, that is sec theta plus tan theta, again sec theta minus tan theta is equal to 1. Here we know the value of sec theta plus tan theta is x. We'll put the value here x, and this one sec theta minus tan theta is equal to 1. So sec theta minus tan theta is equal to x, I will transpose to RHS side, that is it becomes 1 by x. This is one more equation we got here. So by seeing these two observation, RHS we want 1 plus x square, that's why we are going to add equation 1 and 2 here. Adding equation 1 and 2, adding equation 1 and 1 and 2, the results becomes LHS, LHS you need to add, RHS, RHS you need to add here. So LHS, first LHS is here sec theta plus tan theta plus another equation LHS is sec theta minus tan theta. This becomes RHS x plus 1. By adding this one, it becomes 1 by x. So remove the brackets here over here. Sec theta plus tan theta plus sec theta minus tan theta is equal to, I will take an LCM over here. LCM becomes, here you can treat denominator 1, x becomes 1 x, that means x into x, x square plus 1 it becomes. Okay, here tan theta plus and tan theta minus are there, plus and minus get cancelled, so 2 sec thetas are there, 1 becomes 2, that is 2 sec theta is equal to x square plus 1 divided by x. We need here RHS denominator to transpose this to the RHS. It becomes sec theta is equal to x square plus 1 divided by 2x. Hence proved. Hence proved. Okay, next problem is if sec theta plus tan theta is equal to x, then prove that tan theta is equal to x square minus 1 divided by 2x. Here also same the thing. First we have to give an equation I will consider over here, that is sec theta plus tan theta is equal to 1. This one name, this one is equation number 1. Okay, we know that the identity is sec square theta minus tan square theta is equal to 1. This is the identity. So here this is of the form a square minus b square. So first a square, this is sec theta plus tan theta, a plus b, a minus b, sec theta minus tan theta is equal to 1. Here we know the value of sec theta plus tan theta. I will put the value here, sec theta plus tan theta is x here, x into bracket sec theta minus tan theta is equal to 1. X I will transpose to that side over here, that is sec theta minus tan theta is equal to 1 by x it becomes. Okay, so I will name this one equation number 2. By observing the RHS over here, we need here x square minus 1. That's why what I will do, I will subtract equation 2 from 1 over here. So I will write this one, subtract equation 2 from equation 1. Okay, so equation 2 from 1. So first I will LHS I will write the, that is sec theta minus tan theta equation, that is equation 2 from 1. Equation 1 over here is plus actually. You will consider the plus first, then you take the minus. Here sec theta minus tan theta and theta. LHS we have subtracted here first equation. RHS we have to subtract over here. RHS first equation is x here, and minus 1 by x we have to write. So second equation is 1 by x. So minus I will multiply this one, sec theta plus tan theta as it is. If you remove the bracket, minus sec theta, minus into minus plus tan theta is equal to, I will take an LCM over here. LCM becomes x, 1 x is x, that is x into x becomes x square, x 1 becomes, that is 1. So here minus sec theta plus sec theta both get cancelled. Tan 1 becomes 2 tan theta, both are positive. So 1 tan becomes 2 tan theta over here, that is x square minus 1 divided by x. So we need an result proved 2. If you transport that side, that is x square minus 1 divided by 2x. So this is the required result, hence proved. Okay, next problem over here is, if a cot theta plus b cosec theta is equal to p, and b cot theta plus a cosec theta is equal to q over here, and then they are asking over here is p square minus q square. See, by observing this problem, so we come to know that the first equation we have to square first, and second equation also we have to square first over here. Then we have to subtract one in another. Then only we get the value of p square minus q square over here. First, I have to consider this one, a cot theta plus b cosec theta is equal to p. This one I will square it, squaring on both side, squaring on both side, that is a cot theta plus b cosec theta whole square is equal to p square. So this is of the form a plus b into a plus b whole square form. A square in the sense a square cot square theta plus b square in the sense b cosec theta, that is b square cosec square theta plus 2 into a is a cot theta plus into b cosec theta. B cosec theta is equal to p square. So here, by observing this one, a cot theta b square. Okay, so this is, we will this will take this one equation number 1. Name this one equation number 1. Consider again the another equation over here, that is b b b cot theta plus a cosec theta is equal to q. So here also same thing, this equation again squaring on both side, squaring on both the side. So if you square on both side, it becomes b cot theta plus a cosec theta whole square is equal to q square. It becomes q square. So this is also again in the form of a plus b whole square form. That is, it becomes a square in the sense b square cot square theta plus a square cosec square a square cosec square theta plus 2 into a in the sense b cot theta plus into b. This one is a, this one is b. That is a square cosec square theta is equal to q square RHS. Okay, by observing here the required result, we have to subtract both the equation. This is equation number 1 and 2. Subtract equation 2 from 1. So first we have to write the equation number 1 over here. That is p square, that is a square cot square theta plus b square cosec square theta plus 2 into 2 a cot theta into b cosec theta minus of into bracket we have to write here. I don't have a place over here. I will write this one in the second row here. Minus this one equation. So here I will write this one b square cot square theta plus a square cosec square theta plus 2b cot theta into a square cosec square theta bracket close. So RHS becomes p square minus q square. P square minus q square. So this minus I will multiply this whole the bracket over here now. So here b square plus, that is a square cot square theta plus b square cosec square theta plus 2a cot theta b cosec square cosec theta. So minus of b square cot square theta. This becomes minus of a square cosec square theta. Again this becomes minus of 2b cot theta into a square cosec square theta. This becomes RHS, same it is q square. So by observing these two things, here which one will be cancelled? Here 2b. See here 2a square b square. This term will get cancelled. This whole term will be get cancelled. 2b cot theta, 2b cot theta cosec theta. This two will be get cancelled. Cosec square theta, this becomes 2b cot theta. This is not the square. Okay, so this will be get cancelled over here. The remaining terms are here. Okay, I will write a square cot square theta plus b square cosec square theta. Okay, here minus b square cot square theta minus a square cosec square theta. RHS here is p square minus q square. See here common things. My a square cot square theta, b square cot square theta are same. Otherwise, we know the identity, that is you know a square cot square theta minus a square cosec square theta, one identity we will write. And again the same the thing here, uh, plus b square cosec square theta, again here minus b square cot square theta. Actually this becomes p square minus q square, it becomes. Here we know the identity as cosec square theta minus cot square theta is equal to 1. That's why I grouped the same the identities over here. So what I will do, I will take a common from here, minus 1. Actually identity we know is cosec square theta minus cot square theta is 1. Actually here minus cosec square is there, that's why what I will do, I will take a common here minus actually. So what it becomes, minus a square. So cosec square theta minus cot square theta, this is in the form of right actually the cosec square only. So what I will do, I will take a b square over here. It becomes cosec square theta minus cot square theta is equal to p square minus q square. These two, this one is identity actually. Cosec square theta minus cot square theta is 1. So this becomes a square of 1 plus this becomes b square of 1 is equal to RHS is p square minus q square. So here I will write this one as a square plus b square is equal to p square minus q square. So lastly we can write this one as p square minus q square is equal to, value is b square minus a square. This is the required result actually. I hope this will be understand. I hope this problem, I think all of you understood this one. So what I will do, I will once again go through and explain this problem again, because it is a little bit complicated over here. Once again, I will explain over here. By this problem, we understood that we have to square both the equation over here. First, what I will do, I will consider a cot theta plus b cosec theta is equal to p. Required result here is p square. Actually what I will do, this equation I will square both the side. It becomes a cot theta plus b cosec square theta is equal to p square. This is of the form a square plus b square. Here a square a square plus b square of identity is a square plus b square plus 2ab. So here a square is a cot theta, a square cot square theta plus this becomes b square cosec square theta plus 2ab. 2ab, ab is 2 cot theta plus b cosec square theta is equal to p square. So this is the required equation first one actually. And again we are going to consider here second equation, that is b cot theta plus cosec square cosec theta is equal to q. Here also what I will do, this equation second equation also we need q square as a square actually. So both the side what I will do, I will squaring this one. This is also in the form of a square plus b square. It becomes same the way, a square over here is b square cot square theta plus a square cosec square theta plus 2b cot theta into a square cosec square theta is equal to q square. So required result we needed actually both the minus here. What I will do, so by observing this required result, I will subtract equation 2 from 1. I will return the equation whole, first equation 1. See this one as it is I will return. So here minus we required, so minus I return, and again put the bracket, whole bracket, same equation number 2 I written here. One next step what I have did here, so I will multiply this minus whole the this bracket. So this becomes what becomes minus b cot square theta minus b minus a cosec square theta minus 2b cot theta a cot theta. So in this this is middle term is 2a cot theta. If this one is plus, this one is minus, all the term will be here get cancelled agutte. So ivaga enagutte, a square cot square theta minus cosec square theta. What I will do, we know the identity actually here. Cosec square theta minus cot square theta is equal to 1. That is an identity. So what I will do, so I will group these two things, that is cosec square theta cot theta, I will make it one group, and cosec square theta cot theta I will make one group. So here I will take a common minus a square, I will take a common. Why? Because we know the identity cosec square theta minus cot square theta is equal to 1 actually. So that's why I will take a minus over here. This becomes plus in the next step, and this becomes a minus. So cosec square theta minus cot square theta is 1. So this becomes 1. RHS I have written p square minus q square over here. So again, to here this becomes identity cosec square theta minus cot square theta is 1. So minus a square plus b square is equal to p square minus q square. I have written here LHS has required result over here p square minus q square. So b square minus a square is the required result. So this is how.
In the capsule.